Morning, everyone. Today I'm going to start module 3. Yesterday we discussed module 1, module 2, exam question papers. I don't know how many of you listened the class. This is which section? Okay, yesterday I discussed for the same section, right? B11. Anybody is there? Good morning.
Good morning, ma'am.
Today I'm going to discuss module 3. Design concepts. Yesterday we discussed all the question papers, right? For module 1 and module 2 exam papers we discussed. So today I'm planning to take the module 3. Module 3 actually is about designing part. Designing. This is the syllabus, design concepts and architectural design. Design concepts, design within the context of software engineering. Designing, actually, we already discussed about models. Models is part of designing. UML diagrams all comes under this analysis to design. Actually, we are discussing the conversion from analysis to design market. So design within the context of software engineering, design process, design concepts, design model. Then the next part is architectural design, software architecture, agility and architecture, architectural styles, architectural considerations, architectural decisions, architectural designs. So this is the syllabus. Now for every unit, the first slide, I mentioned the syllabus. You have to check whether we complete the syllabus. So you should know about your syllabus first. So in topic, design engineering. What is design engineering? Anyway, engineering means it contains set of principles and practices. So anything which is engineering means design concepts. When it comes to design, we are explaining some practices and principles follow to develop a high quality design. High quality design is good for a high quality product. So engineering, wherever, okay, if you want, if they ask to define anything software engineering or requirement engineering or design engineering. So if engineering is the term, means definitely you can explain it is a branch of science which explain the principles and practices or standards for the development of that high quality product. So that yesterday actually corrected module 1 exam papers and noticed many students. Okay, of course, that copied from the internet. I know that answers, but when you copied, you did not even read what is there in the. You simply copy something under that heading. So many students wrote in the research paper mentioned like that. Which research paper it is? Is there any research paper? You copied from somewhere in that particular research paper, it mentioned like that. But you're saying like it mentioned in the previous chapter, like we mentioned in the previous chapter, those terms also included in the answers. Actually, I had to put 0 mark, even though the answer which you copied is correct. I really want to put 0 mark. Don't deserve any marks actually. How can you write is in this research paper discussed in this way? Really, you are not even reading what is there in the internet. It's not a good practice. Even in the final exam paper also, many students just copied in this way. As mentioned in the previous chapter, as discussed in the first unit, like that terms also there. Yesterday paper correction time also I noticed for 2 mark question also, simple designs, simple definitions only. But still people are copying from the net. It's not a essay type question. Should not repeat it. I will put 0 mark. If any such terms are there in the answers, definitely I will put 0 mark. I won't even read the answers. What is the need? You are saying I copied from the net. It's clear, proof is there in your answer script. How could I give you some marks? So should not repeat it. Okay, when we discussed about design engineering, we discussed about some principles, concepts, practices which lead to the development of a high quality product. So when we discuss about design engineering, we should discuss 3 terminologies: firmness, delight, and commodity. So any product which can maintain firmness, delight, and commodity comes under it's a part of design engineering. So software design is an iterative process. We know that it's not a single stage process. When collecting from the change in requirements, we are repeating all the process again. So of course, it's an iterative process through which the requirements we are converting to a software. So we can call it as a blueprint of the software, blueprint for building software. So this is the input for the coding part. So what do you mean by firmness, delight, and commodity? These 3 terminology you should remember. So a good software design exhibit these 3 properties. One is firmness, means a program should not have any bugs that inhibit its function. So it should not contain any bugs. Then you can call that particular design as firm. It's maintaining the property firmness. Then commodity. Commodity means a program should be suitable for the purpose for which it was intended. For example, you develop a calculator program. The calculator program, what is the intention of the calculator program? You need to do the calculations, whether it's addition, multiplication, divisions, and other square roots type calculations. What are the calculations based on the calculator property, like a normal one or scientific or calculator based on that programmable calculator. So what are the functions you include? That particular software has to perform that function. A program should be suitable for that purpose. That is the purpose of that software. So it should fulfill that purpose. Then only we can call it as a commodity. Then delight means when you use this software, you feel this pleasurable thing. It means its ease of userness is there. Then only you can feel this pleasurable. So the experience of using a program should be pleasurable. Then if any design which maintain these 3 properties, firmness, commodity, and delight, then you could see this design as a good design. Okay. It should not contain any bugs. It should fulfill the purpose, and it is a pleasurable one. So what's the design? Design is the representation or model of the software. Okay, it's a representation. When it's not an executable thing. Model is not an executable thing. It just give you the input to the coding. Coding part, you are doing the actual implementation thing, but you are taking input from this models. So model means it's a blueprint or representation. So when you develop the model, you have to think about the data structure, architecture, interfaces, components. That's why we are creating different models. Model is not a single thing. Component model is the interfaces. We are mentioning interface also in the model, and architecture, the classes, objects, and their time period when it is executing, what messages they are passing in between all the objects. All these things we have to think about during the designing phase. So who does this? Obviously a software engineer. And software engineer means it's a general term for every single task is performed by a specific group, like requirement collection by requirement engineer, design by design engineer, modeling by modeling also a part of design engineers only. Then coding by programmer. So different people. We are using one term, software engineer. Why it's important? Of course, model. If you create a model, we first thing is to study the system. It's very easy. And we can understand the system very easily. If you have a clear picture about the system, then only you could create an efficient code. We should not miss any requirement. So quality is our main intention. So to get a quality product, we need a better design. So we already discussed three terms: firmness, commodity, and delight. So to obtain these three things, suggesting diversification convergence. What is diversification? Means we can gather the information from different repository or raw materials. But we are converging all those information into a single thing. That is, we are collecting the information from different places. Maybe you can go for the previous knowledge. If existing things are there, and go for it. And you can go for the catalogs, textbooks, whatever resources you can collect, the information you can collect. It's acquisition of a repertoire of alternatives, raw material of design. So you can collect the information from different resources. And once the information is assembled, we can pick and choose the element from the collection that meet the requirement. Means you have to convert all these things into a single thing. That is our model. Different models based on different perspectives, you can create different models. But the best one, which is suited for your thing, you can choose. So alternatives are considered and rejected. We have right to reject some models which is not relevant, even though you created some models are not needed. So we have option to accept and reject. So design engineer converges on a particular configuration of component and creation of a file. So the term diversification and convergence is, diversification is the collection or gathering of idea from different materials, and from that you are converge all the ideas into particular model. That is not only single model, multiple models. And once you've done that, you have the right to select and reject, accept and reject. Some models are good for designing, more coding, and some are not relevant that you have to. Then what are the steps for designing? Architecture of system or product must be represented, interface and components model, software components used to construct the system and design. So these are the steps for designing. You have to represent the architecture, then interfaces and components you need to design, and the relationships also. Then work product means what we will get final product as a models. So design model encompass architectural, interfaces, component level, deployment representation, different types of representation that we learned the UML model. We have deployment diagram, we have component diagram. So it represent software and hardware components. And when it comes to deployment diagram, it represent the we are not representing the component inside, but we are representing the node or hardware things with and their relationships like that. For we have different types of designs. What products are there? So how can we assess the model? Assessment means we are checking whether is there errors or inconsistencies or omissions are there. If it is there, and you can choose, we have multiple models, we can go for the better alternatives. And whether it satisfies all the constraints, cost, and time, then you can go for the particular model. So models, actually we learn 9 diagrams, right? All the use case diagram means it represents the user perspective. When it comes to class diagram, represent different type classes and their attributes and operations and the relationship between the classes. When it comes to object, every object we are mentioning with their relationships. When it comes to state chart diagram, we represented the states of operations. And when an event comes, it moves from one state to another state that we are representing. In activity diagram, we represent what are the actions performed by the object. When it comes to component diagram, we represent different components or modules in the software and the relationships. And in nodes represent what are the hardware things, how they are allocating each other. So these are so all these things are not needed for all the projects. Suppose if it's a complex one, you need to draw all these diagrams. Otherwise, if it's very normal thing, you are very much familiar about the project means, so no need to write all the sequence, collaboration diagram. So all the 9 diagrams in that one, some sequence diagram, use case, collaboration, class, object diagrams used to draw for all the projects. The remaining component deployment diagram, sometimes for some project it's not mandatory. So when it comes to elements, what are the elements of analysis model that we discussed? Behavior elements, scenario-based elements, class-based elements. Do you remember that? The analysis model, flow-based elements, different types of elements were there. So we need to convert this analysis model to the design elements. So how can I convert it? Here in this diagram, it shows the analysis model elements. You can see the entity relationship diagram, ER diagrams, data flow diagram, state chart diagram, and common data dictionary is there. Data dictionary contain metadata and other process specification, control specification, object-oriented description things are there. The next slide. So these are the elements of analysis model. When I think this diagram is much familiar to you. This one, this diagram, same concept only. Scenario-based elements, flow-based element, behavioral, class-based elements are there. Scenario-based means use case diagram, use case uses oriented diagram is data flow, control flow, and process specifications are there. Behavioral diagram means state and sequence diagram. Class-based means class, object, CRC, collaboration diagrams comes under class-based diagram. So from this analysis model we discussed in the previous unit, we need to, in the design model, we need to convert the analysis model into design model. How can you convert? So take this input. So for example, class-based like class diagram, CRC models, collaboration diagrams, you have to draw first. And from that, you can create the data and class design in the design model and architectural design. So from the behavioral elements, you can go for the higher level abstraction. That is the component level. And interface design, flow options. These are the, so for the component interface architectural, we get the input from flow-oriented design. Scenario-based elements for interface design. Like that means you can use the activity use case diagram as the input for interface design. So you should remember this very important diagram, which show the translation from the analysis to design phase. So the same thing explained here also, how to convert the analysis model to design model. So these are the input for the design model. Actually, when you draw the phases, analysis design is in single phase, but analysis comes first, then design. Then map, design, system protected. When it comes to the product of the protected, means work protected. After the analysis model, you can state the problem. After the design, we can go for the, we will get the models. Then development time, we will create both models and a solution. Means coding, you at the same time you are creating prototype models. Testing time, what you are testing, the solutions we are testing, whether it is correct or not. So this is the design thing and its work product. So this is the general introduction for design concepts, design within the context of software engineering part. Next is design process. Are you listening? How many of you are listening to the class? Actually, software engineering, you should remember like a story. Otherwise, you can't write answers. This time, probably the end exams, I think it would be physical exam. You should come here and you should write it. Last time, mass copying we noticed. So there is a chance to physical exam and semester exam. So
open the campus now.
Not sure. Not, we didn't receive any circular regarding that. Actually, parents also are willing to send their kids, right? Not sure. Now it's vaccinating, right? Everyone is vaccinating.
Yes, ma'am.
Then before you have to come, you need a certificate. Vaccination certificate, maybe it's mandatory. Otherwise, risk is there. So everyone took vaccines.
Yes, ma'am.
It's going on, right? Not completed. But anyway, it's one dose.
Yes, ma'am.
Some of us completed, ma'am.
one dose. For Covishield, it takes some 3 gap in between, right? The other vaccines, I think, Sputnik, Covaxin, the gap is less. So those people may complete 2 vaccinations. But in near future, we can expect. So what I said, you should learn. You should not think about, okay, at last we can copy something from the net while the end exam is going. It's not possible. You should, every day you have to learn the topics. Otherwise, at last, at the end exam time, it's not possible to learn all the subjects, not only one subject, right? You have many subjects, so it's not possible. So it's better to follow all the subjects, and if you have any doubt, clear it. That now you have more time, you will get more time because you are not even traveling, at home only. So no wastage of time. You can read more, you can learn more. Once you come to the campus, you have to start early morning and you will be reach late, and you are tired. But when you are here at home, you will get a lot of time. Utilize the time and read all the units, all the subjects, textbooks, means at least the online versions are available in the net. Note that even software engineering also online versions are available in the net. Not the edition which is prescribed in the syllabus. That edition is not available. 2020 edition it is. So go for the previous edition. All this text, all this contents are same only. Maybe 1 or 2 topics different. But I recommend everyone to read the textbook. Once you read the text, and after that, if you listen if you go through the PPT, you can recollect all the points. My PPT intention is to recollect the points. For the final exam or for exam, one quick reference material, PPTs. It does not explain all the descriptive. It's not in descriptive manner, right? So the students who are following me in the classes, they're reading something from the textbook, but they will do at last, they will mug up something without knowing the concept. If you mug up, you can't develop the concept. So read the textbook, and if or else if you listen the class carefully, you will get the idea. So once you at last, once you go through the points, you can recollect all these things, what it is. So you should not read only this PPT. PPTs covers all the topics. And last time I noticed, and the students are not writing, they are attending all the questions, but it's not in proper way. Like you should try to answer in a precise way, that I agree, but you should not miss the points. It should be precise and it should be meaningful. For example, and another thing is I noticed for the end exams, suppose if there is ABC sections are there, multiple questions are there in one single question, you are not, so for example, list and explain some concept. So first you need to list it. How we are assigning the marks means for listing, we are assigning 4 marks. Then for explanation, we are giving 8 marks. Okay, this is the way we are dividing the marks. So the one who does not list the things, even though the answer is correct, he will lose 4 marks. So list and explain. First, you read the question carefully. So based on that question parts, we are giving marks. List and explain the characteristics of something. Means you have to list first Then write the explanation. And that too based on the marks. If it is a 6 marks question, you can write very briefly. But if it is a 12-mark question, you should write more points. More elaborate way you should write. So based on the number of marks, you should write the answers. Most of the students made this image. What is, for example, what is software engineering and what are the applications of software engineering? First, you should write what a software engineering is. Then you can go for the second part. Because we have a key. In that key, they clearly mention the marks division. If they attend the first part, you can give this many marks. If they only attended the second part, okay, thus instead of listing that, you are writing the heading name as part of explain. When you explain that, you just write the heading names. I agree that we know that you already aware about the things, but you did not list that. So definitely you will lose the marks. So while writing exams, should be very much careful. Right. First, you read the answers read the questions very clearly and what they want, what they discuss. For example, explain with an example. If that is the question, right, you should explain it. And after that, you should give an example and give the explanation. So the example, if you miss the example and you explain something 5 pages also, you won't get full marks. Because some marks is divided for that example part you missed it. So this is the way we are correcting the papers. So I thought it's better to share with you. Will help you in the next exam. So when we discuss about the design process, are you listening me? I explain some general topic that will be helpful for you in the next coming tips. Okay, design process. Okay, I already said design is a blueprint of the requirement we are representing. It's a representation. We can simply call it as a representation or blueprint of design. So when we're designing also, different levels are there. It means we need go for higher level abstraction to lower level. Higher level means just an overview design, a holistic view. For example, when you design, different levels are there. What that level difference? It is based on the abstraction. It is 0. You just give the higher level abstraction, means only give the overview. You did not mention any details inside. When it comes to DFD1, we store the things, databases you included, repositories you included, right? And we can show. So the processing part, initial part is only overview. When it comes to the internal details, we could see that second iterations lead to lower level abstractions. So you should not disclose everything initially. Like DFT, instead of what is the need of drawing DFT 0? I can draw DFT 1 directly. You feel like that, but you should not do like that way because it depends on the need. We need different level of abstractions. If you show the internal details to the customer, he don't understand anything, and the diagram is very complex. He feels it is very complex and make confusion also. So he will be confused on seeing the internal details. What he can understand it, at what level he can understand. So we should not disclose all that is. So abstraction is very important thing when it comes to the design or analysis or coding also. Abstraction, level of abstraction is very, very important. Then what are the characteristics of good design? It must implement all the explicit requirements, must be readable, understandable, and provide a complete picture of the software. Then we can call it as a good design. Some requirements are implicit, some are explicit requirements. All the requirements we should not explain. For example, ease of usability. That requirement we generally we want as a customer. Okay, when a client comes to you, he may not. In most of the cases, when he explained the requirements at the time, he won't explain his the usability means use not create a complex one. Those people won't say like that. So that is also there are part of requirement. As a design engineer, you should think about that requirements also. So you should consider both implicit and explicit requirements mentioned at the time of requirement gathering. While designing time, you should implement those requirements. So it must be readable and understandable to everyone. Okay, it should be simple. Then quality guidelines. We know that design generated using recognizable architectural styles, components, and this creative in nature. So this is a general thing for a design. And it must be modular. Modular means we can logically partition into different modules. Then only we can work on a separate module and we can reuse it, that module, if you want in the coming projects. And if you want to modify something, if it is logically independent unit, then only you can modify easily on that particular module. And suppose if you want to divide, suppose divide and conquer rule we are applying means if it's a complex project, we divide into different modules and we work on, no, it's not, because this complete project is not done by single person, it's a group work. So if it is logically dividable thing, then only we can allow this project for multiple groups. So design also should be modular. Design containing phase and components. So we should follow some guidelines. For example, when you draw the DFD diagram, DFD process we are representing using bubble, or process simple is there, and repository or databases we are representing using one-sided rectangular, and process we are representing using a rectangular box. So that notations have meaning. You should not mix it. Actually, we in DFD also we learn different notations, ordinal quad method, and one more method is there, right? So if you follow one particular method, you should use the same notations. Otherwise, that is called standard. Okay, it's a standard notation. If you repeat this notation in all your diagrams, no need to explain again what that notation means, because anyone can understand. Okay, he mean an entity. He mean the process. He mean database, like that. The others will get information. No need to explain each and every type. So every single diagram should follow. That's why we learned the UML diagrams with the notations. Each and every notation has its own meaning. Should not mix up all these notations and follow that thing. Then you can avoid the confusion. Our design must carry appropriate data structure and recognizable data pattern should be the, and components, design components, it must that is every component should be standalone. It should be independent. So that's why we call the coupling between the components should be less. A design create an interface which reduce the complexity of connection between the components. Interfaces we are using to reduce the complexity. And design must be derived using a repeatable method because it is iterative. The notation should be used in design which effectively communicate its meaning. This is one I explained. Notations have an effective meaning, so follow the not exact notations should not. For every diagram, you should be familiar with the notations. Then coming to quality attributes, it's one of the important topic. FURBS. FURBS is short form for functionality, usability, reliability, performance, supportability. So these are the quality attributes of the good design. Functionality means it should evaluate the exact feature set what you are planning to implement. The feature set should be evaluated first. Then usability. Usability means overall usability means overall aesthetics, understandability, consistency, documentation, everything comes under usability. It should be usable. Then reliability means actually how reliable the system is. Means the result accuracy and this precision and security of failure, mean time to failure and mean time to recover. Once failure happens, how long it takes to recover. So all these things comes under reliability. When it comes to performance means this processing speed, resource consumption, throughput, efficiency, all comes under performance. Supportability means extensibility is one of the thing. Adaptability, serviceability comes under support. Supportability mainly maintain once after you completed your things, you have hand over and you need to maintain for a period of time. So that also support engineer. What he's doing, if you need extra service, you call the support engineer, right? So if you want to modify or extend, you can go for it. Adaptability means some are not adaptable. So how to improve the adaptability means it should be platform independent. Then serviceability and maintainability all comes under supportability. Then testability, compatibility, and configurability. Testability means whatever you done, that should be testable. Then only we could find out the errors or bugs. And it should be compatible to the higher versions. And it should be configurable. It means we can that software in your system. It should be configurable. It should be testable. You just imagine any apps you downloaded in your mobile phone. Generally, most of the apps satisfy all the requirements. So simply imagine that. Almost all the apps are compatible to different platforms. Sometimes for Apple products, some apps are not working. Most of them designed for Android versions. So that platform independability is also a main factor. So then we need some extra support. So these are the quality attributes, FURBS. Remember the term FURBS: functionality, usability, reliability, performance, and supportability. So any doubt from today's topic? Tomorrow I will discuss the design concepts. Any doubts? Any doubts? Can you hear me? Anybody is there? Anybody is there?
Yes, ma'am.